Hi there, and welcome to our penultimate lesson in our P5 topic, space for reflection. Now we're going to be looking today again at refraction of waves, but this time we're going to be looking at total internal reflection. Anyway, let's go on to our objectives. So for today's lesson on refraction of waves, total internal reflection, we're going to look at what happens to refracted waves when it moves past its critical angle. Okay, so to recap refraction, we looked last time at when a beam of light, a light ray, hits or swaps from one medium to another, it will slow down and therefore change the direction in which it moves. Now, the thing that we need to be aware of is that this original light can change the angle in which it hits. So that's what we're going to focus on during this lesson. Okay, now what we're going to look at is total internal reflection. Now this occurs because of refraction. Now if we put in our normal line here, which is at 90 degrees to this change of medium here, okay, now if we shine light into here and then it can hit where we've got our normal line. Now you might think that we're going to get refraction here, but here we're actually hitting the change of medium at around about 90 degrees, so it's just going to pass straight through. Now if we just alter the line in which it comes in here, so we've now got the light, it's going to come through and we are going to get some refraction. Okay, so we get our angle of incidence here and then we get our angle of reflection here. Now as we move this angle of incidence round here in this direction, we can see what happens to our reflection line, or refraction line, sorry. So as you move it round, this moves round with it until this line actually comes out along this section here, and that is what's known as the critical angle. Now it's actually this angle that is the critical angle. So as we've actually moved this line in this direction, this refracted line has come round until we've got this 90-degree line here. Now if we were to move this light around further, the only direction that this line can actually move in is this way here. And this is what we call total internal reflection. So we've got within that medium, we've got reflection going back. So this light is actually being reflected back into the system. Now total internal reflection has several different uses. It can be used in optical fibres known as fibre optics. It can also be used in bite reflect and also for cat's eyes. Now the way it works is, light will hit the cat's eye, so it will come in, it will hit the change of medium, we get the total internal reflection and it will come out this way. Now it doesn't matter what the direction is, as we will end up with some sort of total internal reflection. So it doesn't matter what angle the light's coming in, we should end up with that change in the light, so we can see where the reflection is. And that works for the cat's eyes and for the reflector. Now with the fibre optic, it works in pretty much the same way, that we get this total internal reflection going off all the way. Now the thing you have to remember with this is the angle. It needs to come in at a certain angle so that we can actually get, you know, a low angle here with a high angle, a big angle with the medium, the normal line here, so that we're able to actually get that total internal reflection. Okay, so we have one more lesson after this, and we have focused on recapping really total internal reflection, and remembering that the critical angle is the angle where it comes off at 90 degrees, and the other angles that we get, remember we need to have a sharp or a large incident angle so that we can actually get that total internal reflection with those. Anyway, I hope you've enjoyed this, and I will see you next time. Take care. Bye bye.